Hey guys, today I wanted to showcase the Adalm Pluto SDR from Analog Devices, and I haven't yet figured out uh, all the features of it, but I basically learned how to code and talk to the device. Um, and the way this is done is via the USB connection or via the Ethernet to USB connection, and the API is using the libiio, which is a proprietary analog devices library. And right now, I just want to show that this was connected. It's like a mass storage inside Adalm Pluto. But that's not what I want to focus on. What I want to focus on is to actually use the objects, and one of them is IIO info, which will give us the available context. As you can see here, this has a really hard time focusing. I don't know if it will even work, but black on black. There it is, PlutoSDR and the USB over IP. And basically at this point that we got the USB context, we can actually go to Visual Studio. I actually compiled their examples. So I set up my own frequency range that I'm going to work with. You can get this from the IIO library. There's a directory called examples, and you can get it yourself. As you can see, I changed the code. The default context did not work for me, but what worked for me were the USB context and the IP context. And I decided to use the IP context because I noticed the USB context changes that number 127.5. It changes, so 192.168.2.1 always stays the same. So I decided to use the IP context, and basically I set it to 1 gigahertz. Let me see if I can focus here. 1 gigahertz transmit and receive. The bandwidth is about 1.5 megahertz, and at 2.5 megasamples per second transmit rate and receive rate. So they have a very interesting library. I'm not going to get into the details of it, but because it's quite complicated, but definitely could look into the buffering scheme. They use a ping pong buffering approach, which is basically you put the samples in, you preempt the samples, and then you empty the buffer, and then you recycle the buffers that way, kind of like almost like a graphics or audio backend buffer or whatever you want to call it. So they flip the buffer, the empty buffer, and the full buffer. They preempt it that way, so you always have an empty buffer being pushed to the front and getting filled while the other one's preempting out. So it's like I said, a very clever scheme. And then let's just run it so we can show it works. Okay, and you can see some action here. This is going to be very hard to focus. Let's see here. Anyway, I think it's plugging in about 10 million samples per second on the transmit side, and the receive side receives the data. And let's go one step further and show that this is happening, and it is real, and it can be traced I don't need to have a demodulation scheme for it, but it is possible to do. That's one of the pluses of Adalm Pluto, is that you could do that. You can modulate data via the IQ signals in and out. Here we go. So there we are. That's the actual let's see if we can center it better. Probably not. Okay. There it is. Yeah, so that's about 1 gigahertz. I have not yet figured out how to stop it. If you actually stop the software, the buffering will still run. So let's do that. Let's just go to Visual Studio, the debug mode, and stop it. So what you will notice is that it'll keep running. Can you see? So one way to get around that is obviously to disconnect the cable, and then you'll see that I stopped the transmission. That was a 1 gigahertz. Their example runs at 2.5 gigahertz. I tested it. It works great. I just need to get a better handle on the frequency calibration, because it seems to be slightly off. I don't know by how much, but it's slightly off. That wasn't exactly 1 gigahertz. So there's probably a way to calibrate the software, and I'll work on figuring that out. Anyway, so that's the Adalm Pluto, a great SDR. I've actually tested it with some SDR channels on FM and even on ham radio, and it works great. It has a lot of range. I think it goes all the way up to 7 gigahertz, but don't quote me on that. It's ridiculous how high up this thing can go. And I was successful getting the libiio compiled on Windows, and that's a major plus. I don't have to use just MATLAB. I can now create my own modulation and demodulation scheme, and create means to send it samples to the modulator and demodulators. You can create filters. It's crazy how much this thing can do. Anyways, and it runs on Linux. Okay, well, that's about it. That's all there is, and if I find out more, I will post it on video. All right, bye.